homework then? 33? We're on page 80, is that right? I gotta get my brain in the right place. Oh, this is a fun one. Tangent x over sine x. So we want to find all vertical asymptotes of the graph. And it says to describe the behavior, but I told you just to find the asymptotes, I think, right? All right, so tell me what vertical asymptotes, just as a refresher, how do we define vertical asymptotes? Do you remember? That's exactly right. All right, so let's see first. Let's see first if anything cancels here or anything. Or actually, what we can do before we do that, where is this equaling 0? Because those are going to be my undefined points, right? So sine of 0 is 0. So when x is 0, where else? Pi. Negative pi and 2 pi. Every pi, in other words, right? I've got to get my brain back in the game and remember how I... All right, so do we agree that that is where we're undefined in our function? Yes, no, maybe so. Let's do some algebraic manipulation and see what happens also. The tangent is the same thing as what? Sine over cosine or cosine over sine? Sine over cosine. I'm going to multiply by 1 over sine, right? Agree or disagree? So what should I do to find the... Avery says she graphed them. What did y'all do? Graphed them? So I guess my question is, are the asymptotes happening where sine is 0, or is it happening where cosine is 0? Cosine is 0? Graph it and see what happens. Let's put it on the calculator. Tan x divided by... I'm thinking everywhere sine x is, there's going to be a hole, since essentially it cancels, but everywhere that cosine x is, there's going to be an asymptote. What you think? Let me show you what's happening here. So your first instinct going one like this might be to say, well, I have vertical asymptotes at every k pi, right? But that's not actually what's happening. Where's my... And let me show you why. Remember we talked about holes as opposed to asymptotes? And holes happen whenever it cancels out in the top and bottom, right? It's just a place where it's undefined. So looking here, this is where the bottom equals 0, but yet it cancels out. So these are going to be my holes or my undefined. They're not necessarily asymptotes. My asymptotes are going to happen where this true bottom equals 0, which if you look on your calculator, so I've got tangent x over sine x, right? It's not actually happening at every pi, it's happening at every, well, it's pi across, but what is that? Half pi. 3/2 pi. Because that's where cosine x equals 0, right? Where does cosine x equal 0? That's when x is dot, dot, dot. Pi over 2, 3 pi over 2. If you do zoom 7, that's trig. That takes you by half pi's across. And if you look, if I go into my table here, second graph, and I do 0, you'll see that I do have an error there, even though it looks on the graph, you know, it looks like there's a point there. So this is actually the cosecant graph. Nope, secant graph, right? Yes, secant graph, sorry. This is the secant graph, but it's not defined at every pi. So those aren't in the domain, but they're not asymptotes, yeah. My calculator just graphs asymptotes. Yours probably doesn't. It's not a good thing that mine does. It's just an older calculator. Does that make sense to everybody? There's just a hole at 0. That's exactly right. And we'll talk about how we plug that hole today, actually, maybe. So you could say this one of two different ways. What did it ask you? Let's see. What are the equations of the asymptotes? So the asymptotes here, you could do it this way. Or you could say x equals and I would probably say, actually, let's do pi over 2 plus k pi, where k is an integer, because they're still spaced out pi units apart, right? That way I don't have to worry about saying it's an odd pi up top. But either way, either one of those would suffice. What else? Yes. I didn't want you to do that part. Just do the asymptotes. We didn't talk about in-behavior model. Essentially what an in-behavior model does is it takes it's kind of like whenever the powers are the same and you take the leading coefficient of the top and leading coefficient of the bottom. It's just finding a function that would represent, because the further out you get, it's okay. Just do the horizontal asymptotes, and most of those are top heavy, bottom heavy, same. What else? Y'all good? Was it easy? 43. F of x equals 4x squared. Oh, geez. Just to let you know about the in-behavior model, it would just be, instead of just the leading coefficients, it's the whole first term. So 4x cubed divided by x would be 4x squared. The in-behavior model would be 4x squared. And that just means that the ends of the graph are going to do the same thing that a 4x squared graph would do. So both would be up, right? If I've got 4x squared, that's a even positive, so both ends go up. You remember learning about that? Do y'all remember that? So if it's an even degree, like a parabola, both ends go the same way, depending on if that a is positive or negative. If it's positive, both ends go up. If it's negative, both ends go down. Well, that's true for any even degreed function. And then the odd degree, just like a line, they go off in opposite directions, depending on positive or negative. And that's all in-behavior model does. But for this one, it asks you for horizontal asymptotes. So this one is top heavy, which means what? No asymptote, that's right. That's all you had to do for that one. Were you confused because it said in behavior model? It does have a vertical asymptote, yes. Yeah, no horizontal. It does have a vertical asymptote. Where's the vertical asymptote? Here, where the bottom equals 0. Unless it's a trig function, in which case you have to kind of think about where it's undefined. But also remember, if the factor cancels out top and bottom, it's a whole, not an asymptote. So you have to look. Like I knew that this didn't factor. This was a cubic, right? A trinomial cubic, and that's not going to factor for me. So nothing would cancel. Like if I ended up with, if I factored it down and I got something like 3 is a whole, but -1 is a vertical asymptote. Yeah. Somebody, did y'all? 52? 3? Find the, oh, this is a good one. Lots of piecewise. Calculus loves piecewise. Especially when we start talking about continuity today. Find the limit as x approaches -infinity, +infinity, 0 from the left and 0 from the right. All right, so as I approach, we'll do -infinity first. All right, so let's think about these graphs for just a minute. This is that parent graph. This is that reciprocal function, right? So it's going to do something like this, but we know that it had a vertical asymptote at 0 because of the bottom there, and we know it's bottom heavy, so it had a horizontal asymptote at 0. So the limit as I approach -infinity, so the first thing I need to do is which function am I looking at, the first one or the second one? The first one, because it's -infinity, and this is less than, right? So here, and remember, because this is less than, I'm only looking at this side of the graph. Once it goes past there, it's -1. Yes? Okay. So what's the limit as I approach -infinity? Okay. It's okay. So altogether, this piecewise function would do this. This piece is the left side, and then the right side comes in right here and does this at -1. So altogether, that's the graph I'm looking at as I look at my limits. So if I didn't have the graph, I would know that for this one, the left, I'm using this equation because this is where x is less than 0. And since I'm approaching -infinity, that's really small. So what's the limit as x approaches -infinity? 0. 0, because there's a horizontal asymptote, right? Right there, 0. How about the limit as x approaches +infinity? This time I'm using which equation? The second one, because that's the one where x is getting bigger and bigger. So as I approach +infinity, what's the limit of f of x? -1. The limit of a constant is the constant itself, right? Are y'all okay there? Sure? Because it's +infinity, that's right. And this is where x is bigger than 0. You really don't even need the graph to do this. All you need is the equations. But just to show you that it backs up graphically. How about 0 from the left? Which equation are you using? The first one. Does everybody see that? This equation is from the left because it's less than. So what is the limit as I approach 0 from the left? And this one, if you get confused, it's a little bit easier to look at the graph to see. But what is it? Negative infinity. Because it's going down, right? That's on the left side of 0. How about the right side of 0? This side. So what's the limit as x approaches 0 of f of x? Good job. I was trying to trick you. It does not exist. Why does it not exist? Limit from the left is not the same as the limit from the right. Good job, y'all. The asymptote's coming in from this piece of the graph because, yeah, it's approaching negative infinity. That's exactly right. You approach a constant and get an infinity, it's a vertical asymptote. If you approach infinity and get a constant, horizontal asymptote. Did I have y'all do 34? Or 50, I mean 54. 54. No? Let's do that one together because these are important, especially with our continuity we're going to talk about. So this one's very, very similar, but it's a little bit harder because it's not quite as easy to graph. Let's do it together. Tell me what you know about this first function as far as asymptotes go. Does it have any? It has a vertical asymptote at x equals 1, horizontal asymptote y equals 1 because the degrees are the same. Everybody agree there? How about the second one? Okay. You look at the degrees, top heavy, bottom heavy, same. So since they have the same degrees, it's the leading coefficients, which are both 1. So 1 divided by 1. Remember that? So if they have the same degree, let's say it was 3x squared minus 5x plus 2 over 2x squared plus x minus 1. This would have a horizontal asymptote of 3 over 2 because they have the same degree, top and bottom. All right. What about the second one? Any verticals? Where? Horizontals? Where? Bottom heavy, so it's 0. All right. Well, when the bottom equals 0. That's okay. Did we talk about slant asymptotes in pre-cal? All right, let's do the limit as x approaches negative infinity. Which function am I using, the first one or the second one? The first, because it's negative infinity, that one's less than 0, right? So what is the limit as I go to negative infinity here? What do you think? Why? There you go. So you can do it that way. So did y'all hear what she said? Plug in infinities there. You get 1. I also know there's a horizontal asymptote at 1, right? So any of those ways would work to find out you actually have a horizontal asymptote. How about positive infinity? Why? There you go. Using the second equation, 1 over infinity squared is 1 over huge squared, which is goes to 0. Good job. Y'all are getting this. How about the limit as x approaches 0 from the left? Y'all are thinking real hard about it. What should you always try to do as you evaluate limits? What should be your first step? Substitute. Can you substitute? Sure, why not? Using the first equation, 2. There you go. 2. How about the limit as x approaches 0 from the right? I can't plug in here, right? You have to use that very first equation. Any guesses? What do you think? It's greater than 0. It's coming in from the right, so I'm definitely using the bottom equation. So I'm 1 over x squared. There you go. Infinity, because I know that this one has a vertical asymptote at 0, right? So as I approach 0 from the right, and I'm using that equation, it's got to be infinity. Feel okay? Y'all sure? Well, what I'm thinking is because it's squared, it's going to always be positive, right? No matter what you put in, it's always going to be going positive. So it's always going to be going up. It's never going to go down. That'll never be negative. Anything else from y'all's homework? I know that one wasn't on your homework, but I feel like y'all need to do like a get up and move and wake up or something. Find this limit. Any ideas on? Yes. Substitute? Can you substitute? What would happen? Let me ask you this. Could you write this any other way? Could you rewrite anything here? Which one or what? Okay, so the natural log is the same thing as what? Log base e of x over log of x. I can't condense unless I'm saying bases. There's not really anything I can do there. Can you think of anything you could do? You think? Is there any way to force them to have the same bases? Let me ask you that. You'll be guessing correct. Do you remember how to do that? You can rewrite any log in any base you want. Do you remember how? No? Change of base. That's exactly right. Do you remember what change of base is? If I have the log base b of a, I can rewrite that as log of a divided by log of b, and I can have any base I want right here as long as it's the same. And we used this whenever I first taught you about logs, whenever your calculator would only do base 10. You remember that? I said, well, if you've got a calculator, then what's log 5? What's log base 10 of 5? And well, you can rewrite that, or let's say log base of 5. Sorry. You could rewrite that as log 5 divided by log 2 and get an answer because your calculator will do base 10. But we said it doesn't really matter what base you use. You can rewrite it. So now what do you think you could do over here to get them in the same base? Shall I go base 10 or shall I go base E? Base 10. I would go base 10. Let's see what happens. Rewrite this in base 10. Yes or no? What you think? See anything that happens now? Those log x's are going to cancel out, right? Because I have log x over log e times 1 over well, all of a sudden, what do you notice has happened? There's no x. What does that mean when there's no x? It's a constant. What's the limit of a constant? The constant itself. You can get a value for that on your calculator, or you could leave it exact just like that. Well, since it's base 10, calculator does base 10, just hit log and then the E button. I think it's second ln. You have to do like E to the first, but so good. I think you get like 2.3 maybe. Is that right? Let's do a little review for tomorrow. Don't tell the answer when you get it. Find the limit, if it exists. Anybody got it yet? Does substitution work here? Why? That's right. There's a hole there. What do I need to do first? Or what's a good first factor? Factor at the top. X minus 3, x plus 2. Agreed? whole at 3. So now I have the limit as x goes to 3 of x plus 2, which is 5. Everybody get 5 there? What kind of discontinuity is that called? Removable or non-removable? Removable. Why do we call it removable? There's a hole and I can remove that algebraically. So it's called a removable discontinuity. How about this one? Find the limit as I approach 2 from the right if f of x is 3x plus 1. Or which equation are you using? Bottom. 2 from the right. This one comes in from the right. So really I'm looking at the limit as x approaches 2 of 5 over x plus 1. Can I sub? Sure, I can sub. Get 5 over 3. Everybody good on those one-sided limits like that? Speak now or forever hold your peace. No, not if you're asked just to find the limit now. You're doing a lot. Look at this graph. I'm trying to model these after your quiz so you'll know what to expect. What is the limit as x approaches -3 from the right? Two. What is the limit as x approaches as x approaches 5? Oh, good job. That's right. What's the limit as x approaches -1? Does not exist. Why does it not exist? The left and right are different. That's exactly right. What is the limit as x approaches -1 from the left? Yeah, that's right. How about from the right? what is f of 5? Everybody sees why? It's defined here, but the limit is not there. Everybody okay on analyzing a graph that way? Okay. So the limit as x goes to 5 is -1 because the graphs are getting closer and closer to -1, but there's a hole there. The function is actually defined at 1. If a f of, right, because there's that circle there. Well, because the limit is what it's getting close to, right? So if you look, this graph is coming in closer and closer to -1 from both sides. So the limit as I approach 5 from the left is the same thing as the limit as I approach 5 from the right, which is -1. But the function itself is defined to have a value of 1 when x is 5. So when you're looking for function value, you're looking for that closed dot. You're looking for where it's defined. That's okay. I'll give you a second to catch up. What in the heck am I going to do? I can't plug in. Coming from the left, from the right. Graph, is that what you said? Tell me what you know about it before I graph it. There's a vertical asymptote at 2, horizontal at 1. Everybody agree? Yes, because it's the same degree. Yeah. We'll graph it and see what happens. See what you think as you approach 2. And I know that that's where there's an asymptote, right? This would be a calculator problem, by the way. I know it's going to do something like this. I just am not real sure where my little pieces of my graph are. Is that what y'all got when you graphed it? Looks something like that. So the limit as I approach 2 from the right would be Khalil stood at the top of a tall cliff this weekend. Picks up a rock and throws it over the cliff because he had a bad weekend. The rock, the rock falls. He won't tell anybody about it though. Clearly, y'all know. The rock falls to the ground at a rate of 16 t squared feet in the first t seconds. What is the average speed of the rock during the first 8 seconds? Y'all remember what to do? Well, this is average. This is your average rate of change. So how do I find average rate of change? So you put the 8 in for the t, is that what you said? Find the 2 points, you're exactly right. Find the 2 points and find the slope between them. What 2 points? Well, your starting point, which is obviously at time 0, and at time 0, what is your speed? 0. He hadn't hurled that rock yet because he's not mad enough to do it, but then he's mad enough to do it. And 8 seconds later, here's where you plug it in. What's the speed? 1,000? So the average rate of change is going to be the slope between those 2 points. Oh, thank you. Remember that, A-Rock? All right, so my average rate of change is going to be 1024 minus 0 over 8 minus 0, which is 128 feet per second. Get in the habit of putting your units on there because you get points off if you don't include your units on the exam. What is what's the speed of the rock at exactly 8 seconds? Remember, this is where I want my delta x to be 0. This is where we went through all those calculations, and I told you didn't have to do it again, but be familiar with that formula because we'll do it again later. But really, all I did was 32 times the time there, right? So 32 times 8, which is 256. Vastly different than the average rate of speed. Say that again. The speed at exactly 8 seconds is where I find the rate of change. Rate of change is the feet per second. Say that again now. Ask me one more. Right. No, because that's not giving you the speed. That's giving you the velocity. Right? It's giving you the. It's not giving to find the speed. We want to do the rate of change. Speed is always going to be your rate of change. This is your, what is that, y'all science people? The gravity? Is that what it is? The force of gravity on it? Something like that. So to find how fast it's actually falling. Yeah. This will make a whole lot more sense when we get a little further into our derivatives and stuff and you see what exactly we're doing. Let's take a little break.